This presentation is all about expected values of continuous random variables. So first, we define continuous random variable. So a random variable x is said to be continuous if it can take on the infinite number of possible values associated with intervals of real numbers. So a continuous random variable takes an infinite number of possible values. Unlike discrete random variables, which is usually countable, a continuous random variables are usually measurements. For example, a weight of students in a class, amount of lemonade in a jug, time it takes to run a race, and etc. So to find the expected value, also known as the mean, and the variance, we use the following formulas. For the expected value, we use the formula mean is equal to the expected value of x, which is equal to the integral from negative infinity to positive infinity of x times f of x. And to calculate the variance, we use the formula the variance of x is equal to the expectation of the quantity x minus mean squared. And to find this expectation, we will derive at the integral of the quantity x minus mean squared f of x over all the positive values of x, which is also equal to the expected value of x squared minus the square of the mean. Example number 1. For a lay in a machine shop, let the x denote the percentage of time out of a 40-hour work week that the lay is actually in use. Suppose x has a probability density function given by f of x is 3x squared when x is between 0 and 1 and 0 elsewhere. Find the mean and variance of x. To calculate the mean, we will use the formula we discussed earlier. So by direct substitution, we will get the integral between 0 and 1 of x times 3x squared. By simplifying, we will get the integral from 0 to 1 of 3x cubed. Integrating 3x cubed, we will get 3 times x raised to 4 over 4 evaluated between 0 and 1, which is equal to 3 over 4 or 0.75. So, on the average, the lay is in use 75% of the time. Note that we integrate between 0 and 1 because the integral from negative infinity to 0 is 0 and the integral from positive 1 to positive infinity is also 0. To calculate the variance, we will first get the expected value of x squared, which is equal to the integral of x squared times f of x over all the possible values of x. By direct substitution, we have the integral between 0 and 1 of x squared times 3x squared. Simplifying x squared times 3x squared, we have 3x raised to 4. So when we integrate 3x to the 4th, we get 3 times x to the 5th over 5 evaluated between 0 and 1. And that is going to be equal to 3 over 5 or 0.60. So now we have expected value of x squared, which is equal to 0.60. So to calculate the variance, we will just substitute the value of expected value of x squared minus mean squared, which is equal to 0.60 minus 0.75 squared is equal to 0.0375. Example number 2. The weekly demand X for kerosene at a certain supply station has a probability density function given by f of x is x when x is between 0 and 1, and 1/2 when x is between 1 and 2, and 0 elsewhere. Find the expected weekly demand. So to find the expected weekly demand for kerosene, we will use the expected value of x. Since it is a piecewise function, we will add x when x is between 0 and 1 plus 1 half when x is between 1 and 2, because the two is different functions with different intervals. Therefore, we have the integral from 0 to 1 of x squared plus the integral from 1 to 2 of x over 2. Thus, when we integrate x squared, we have x cubed over 3 evaluated between 0 and 1 plus when we integrate x over 2, we have 1 half times x squared over 2 evaluated between 1 and 2. And that is equal to 1/3 plus 1 half times the quantity of 2 minus 1 half, which is equal to 13 over 12 or 1.08. Therefore, the expected weekly demand for kerosene is 1.08 times 100, which is equal to 108 gallons.